Hello friends. So let's start with the question number 10 of partial differentiation of second order. So here in this question the given function is very big and guys you have to prove the result, which is again a big result. So let's see how to solve such type of numericals where a function is big and the result is bigger. So here u is given as a into r to the power n plus b into r to the power negative n cos of n theta minus alpha. So guys, here there are many variables and the constant. So let me tell you that a, b and n as well as the alpha are the constants and theta and r, they are the variable, and you have to prove this result. Now guys, to prove this result you have to find out del square u by del r square. It means differentiate u twice with respect to r. Then for getting this value we have to differentiate u twice with respect to theta partially, and then we'll get the answer. So let's start. So let's find out the value of del u by del r first. So this value will be covered. Again we'll differentiate this with respect to r to get this value, and for that we have to partial differentiate this given function with respect to r. So here we'll get del u by del r equal to, now guys, if you observe this given function, then cos of n theta minus alpha does not have any r, so we'll treat it as constant. It will come outside and we'll just differentiate this term with respect to r. So a as it is, the differentiation of r to the power n is n r to the power n minus 1. Then this b as it is, plus, I know there is a plus, and the differentiation of r to the power negative n is negative n, so this positive will become negative, and r to the power negative n negative 1. Now here we got the value of del u by del r. We can again simplify it. So for that we'll take this n outside and remaining terms will remain as it is, but I'll keep it as it is for time being, and I'll directly differentiate this function with respect to r. So here I'll say so guys, now if we differentiate this function again with respect to r, this cos of n theta minus alpha is a constant, will remain as it is. And now we'll differentiate this function. So a and n both are constant. Derivative of this with respect to r is now let's find out the value of del square u by del theta square, and for this we'll differentiate u with respect to theta. So therefore we'll get del u by del theta equal to, now guys, in the first function there is no theta, so we'll treat this as constant and we'll just differentiate the second term with respect to theta. So we'll get negative sine of n theta minus alpha into n. Now to get this del square u by del theta square, we'll again partially differentiate this u, that is this del u by del theta with respect to theta. So now guys, here this negative n is constant, a r to the power n plus b r to the power negative n constant, and derivative of sine term is cos of n theta minus alpha into n. So here if I simplify this, we'll get negative n square a r to the power n plus b r to the power minus n into cos of n theta minus alpha. So guys, here we got this value as well. So we got all three values. Now what we'll do is, to prove this result, we'll put all these values here and then we'll add it and we'll show that it is equal to 0. So first value del square u by del r square, which is this value, I'll put it there. Then the second value is del u by del r, which is this value, and to this value we have to divide by 1 upon r, or I would say we have to multiply by 1 upon r, or we have to divide by r. Next, third value del square u by del theta square, and for this value we have to multiply by 1 by r square to this value. Now guys, if I observe these three terms carefully, then in this answer, or in this term, and in the last term, we have cos of n theta minus alpha same in all the three terms. So it means we can take that common. So I'll take that cos of n theta minus alpha common, and I will write down the remaining terms as it is. So I'll take it common, and in the bracket the first term is del square u by del r square. So this is the value. I've taken this common, so these terms will remain in the bracket. So now guys, this is the second term, that del u by del r. We have to multiply it by 1 by r. So if I multiply this with 1 by r, correct? So it will change, but cos of n theta minus alpha we have already taken it outside. So if I multiply it by 1 by r, so it means r will go in the denominator here, as well it will go here, because we are multiplying with 1 by r. Now this r will come in the numerator, and that will become r raised to n minus 2 in both the place. So here we will get plus a n r raised to n minus 2 minus b n r raised to negative n negative 2. Now let's talk about the last term, that is the value of del square u by del theta square, for which we have to multiply by 1 upon r square. So if I multiply this term with 1 upon r square, that r square will come here, and here, and we'll take this cos of n theta minus alpha outside the bracket as a common term. So we have taken it outside. So here we will get negative n square. This r square will go in the numerator, and that will become r raised to n minus 2. So negative n square a r raised to n minus 2. Similarly here negative n negative 2, and this will become negative n square into b into r raised to minus n minus 2. So negative n square into b r raised to minus n minus 2 equal to, so it means we have to find out this value. So I'll not write equal to, because we have to prove that this value is equal to 0. So you may call it as LHS or any term. Now let's start. So I'll call it as LHS and I'll continue. So guys, so now let's start. So here also I'll call it as LHS. Here I'll write it down. So we are solving the LHS and we are going to prove that it is equal to 0. So cos of n theta minus alpha as it is. Let's solve the bracket. So this will become a n r raised to n minus 2 into n is a n square r raised to n minus 2. Then a n r raised to n minus 2 into minus 1 is negative a n r raised to n minus 2. Similarly, we'll multiply over here. So we'll get plus and here we will get bn r raised to minus n minus 2 into 1 as plus bn r raised to minus n minus 2. Now remaining terms we'll copy it as it is. So here plus. Now guys, let's check if we can cancel any terms. So here we have a n square r raised to n minus 2 positive, and the same term we have here which is negative. So we can cancel these two terms. One is positive, one is negative. Next, we have negative a n r raised to n minus 2. Here we have positive a n r raised to n minus 2. We can cancel these two terms. Then positive b n square, and here negative bn square. So we can cancel these two terms, and again negative bn r raised to minus n minus 2, positive bn r raised to minus n minus, we can cancel this. So it means guys we are getting nothing, it means 0. So 0 into cos of n theta minus alpha is 0, and we can say that it is equal to RHS. So here we have proved that it is equal to 0. So we have proved the result. So guys, I am sure that you understood how I got the result. So here I have done with my part. Now it's your turn. You have to promote this video with your friends so that they can also get this solution and they can also get good marks in the subject of engineering mathematics. And don't forget to subscribe to this channel to enjoy more videos of engineering mathematics and other subject of engineering. Thank you very much.